8th grade math, test 11, study guide, problem number 1. So problem number 1 says, which point shows rad 56 on the number line? Well, the square root of 56 is in between these two perfect squares, these two consecutive perfect squares. 8 times 8 is 64, and 7 times 7 is 49, so it's in between those two, which means rad 56 is in between 7 and 8, or it's 7 point something. But we already knew that by looking at the number line right there. We just got to figure out 7.1. So we're basically estimating this to the nearest tens. So if I see how far away 56 is from 49, in other words, if I subtract those two, I see it's 7 units away. And this one's 8 units away. So it's actually kind of right in the middle, just a tiny bit closer to that. So it's like 7.4, 7.5-ish, around there. And the only point that would work on the number line that they gave you, the one that's right in the middle, but a little bit bit to the left, would be the 1, 2, third point from the left. So the answer would be the third point from the left. Okay, problem number 2. T says, given the following numbers, we're going to say what's true. Well, if you guys have a repeating decimal, that's rational. If you have any regular fraction like that, as long as it doesn't have pi or a irrational number, that's rational. So regular fractions are rationals. And anytime you have a perfect square inside of a radical, so those are all rational. So my answer has to be C. None of these are irrational. Number 3. We have 4 to the 7th power times 4 to the x power equals 4 to the 10th. We've got to find x. In other words, 7 plus what is 10? So my answer has to be 3. This is where we copy the base and add the exponents. Number 4 says we're going to simplify 2x to the 4th power, y to the 4th, all times 7x to the 7th, y to the 5th. Make sure I copied that correctly. This is multiplication, so I multiply my coefficients. 2 times 7 is 14. Multiply my x's. I copy the base and add the exponents. 4 plus 7 is 11. And then I do my y's. Copy the base and add the exponents. And there's my answer. Number 5 says we're going to evaluate a to the negative first times b to the 0. Well, anything to the 0 power is 1, so cross out your 1s. They say a equals 4, so I got 4 to the negative first power. 4 to the negative first means I got to flip it and make it 4 to the positive first, so I got 1/4 is the answer. Number 6 said we're going to simplify 55 r to the 8th s divided by or over 5 r squared s to the 6th. Well, like this one over here, we do our coefficients and then the powers with the same base, but this time I'm dividing because over means dividing. So 55 divided by 5 is 11. R to the 8th divided by r squared is r2. This is where we subtract the exponents. 8 take away 2 is 6. And this is s, which is s to the first, so it's s to the 1 take away. Let me show you this. 1 take away 6, add the opposites, 1 is s to the negative 5th power. Negative exponents are not simplified, so we have to flip just the one that has a negative exponent, which is only the s to the 5th. And once we flip it, the negative exponent becomes positive, so there's our answer. Number 7. 7 says, decide which expressions below are equivalent to, go up here, 3 to the negative 2nd power times 3 to the 3rd power, all to the negative 2nd power. It's always a good idea to check real quick, make sure you copied it right. Okay, so this is what we can do then. Now, what we normally do is we take everything in here to the negative 2nd power. Okay, that will always work. But since these are the same base this time, we can actually take a shortcut there. And we can combine those two first. But you know what? I'm not going to teach that to you, even though that's the easiest way, because once I change the bases, if you try to do that, you're going to be wrong. So I'm just going to take everything in here to the negative 2nd power, because that way it always works, even when we don't have the same base in there. It always works. Okay, so I took this to the negative 2nd power and this to the negative 2nd power also. Now, when I have power next to a power like this, that's not when I add my exponents like down here. That's when I multiply. So I go 3 to the negative 2 times negative 2 is positive 4. Remember, Mr. Dude? Negative times negative is positive. Over here, 3 to the positive 3 times negative 2 is negative 6. So now I'm multiplying powers at the same base. Copy the base, subtract the exponents. 3 to the negative 2nd power is the same as 1 over 3 to the 2nd power Negative exponent means flip, right? And then, which is 1 over 9. So if I look at all these expressions, expression number 1, 3 to the 4th power times 3 to the negative 6th power. Expression 1, we have 3 to the 4th power times 3 to the negative 6th power. Well, I copy the base, add the exponent. That's the same. Number 2 says 3 to the negative 4th times 3 to the 6th. Well, that's where I copy the base and add the exponent, so that's different. Number 3, the number 9, well, that's not the same because it's 1 over 9. And number 4 is 1 over 9, so my answer is 1 and 4. Alright, and then you had to pick for that choice D, which is 1 and 4. Number 8 says 2 to the 4th power times 3 to the 6th power times 4 to the 2nd power, all divided by 2 to the 2nd power times 3 to the 5th power times 4 to the 2nd power. The last thing you want to do here is start multiplying these big numbers. Instead, you want to use your properties. I'm going to divide powers with the same base. I copy the base, subtract the exponents. Copy the base, subtract the exponents. And these are the same thing, so I can cross out my 1's right there. Or I can copy the base, subtract the exponents. 2 take away 2 is 0. Like we said earlier, anything to the 0 power is 1, so just cross out your 1's anyways. 2 to the 2nd power is 4. 3 to the 1st, multiply, and you get 12. Remember to do the exponents. Don't multiply these two to get 6 first. Do a 2 squared first to get 4. 4 times 3 is 12. Number 9. Number 9 says, about, oh, we like that word about. About how many times bigger is 9 and 9800ths times 10 to the 7th power than, that means over, 9 and 998 thousandths times 10 to the 6th power. Okay, so I put the bigger one on top when they say how many times bigger. Okay, since they said about, I get a round. 9.98 is basically 10. And 9 and some other mess is basically 10. 10 divided by 10 is 1. And 10 to the 7th divided by 10 to the 6th, I copy the base, subtract the exponents. 1 times 10 is 10, so it's about 10 times bigger. Number 10. So the epic fail video received 6 times 10 to the 8th views. The funny cat video received 3 times 10 to the 3rd views. And it says, how many times more views did the fail video receive than the cat? So if this says how many more times than this, I put this one on top. Okay, so I divide. 6 divided by 3 is 2. 10 to the 8th divided by 10 to the 3rd. Subtract the exponents. So it's 2 times 10 to the 5th times bigger, or if you wanted to convert it to standard or decimal notation, you move the decimal 5 times or add 5 zeros. 1, 2, 3, 4, 5, or 200,000 times bigger. Number 11, we have negative 5 to the 14th times some number equals negative 1/7. So we're going to figure out what that number is, or in other words, we're going to solve. So separate our left from our right sides. When I have a fraction in front of a variable and I need to isolate that variable, what I do is I multiply by the reciprocal of that fraction to both sides, and that will isolate that variable. So now I have negative 1/7 times another fraction. Negative 14 is 2 times 7 over 5. And negative times negative is positive, so I can use Mr. D to get rid of that. Or you can put the negatives up top like I taught you. Cross out your 1's and the answer is 2/5. Number 12. We're going to solve negative 3/8 times P equals negative 38. So what number do I multiply to negative 3/8 to get 38? Well, I can isolate the variable by dividing by the coefficient. Again, negative divided by negative is going to be positive. 38 divided by 3.8. Remember, when you're dividing by decimals, you want to clear the decimal for the outside, the divisor. So if I move this once, I got to move this once here too, put it up top, and you get P equals 10 for number 12. Okay, so now we're on 13. Let's go up here for 13. 13 says, we're going to write and solve an equation. It says you had some money, you got a certain amount of money for each seashell, and then you had a total. And it says, question is, how many seashells? So when they ask us something, figure out what the question is, then let the letter equal that. Assign a variable. So S is going to be the number of shells that you found. Okay? Now we're going to make sense of this problem. So there's a total amount of money, right? And that's going to equal the money that we had and the money that we get. And I hope that makes sense to you, right? All your money is what you had before plus what you get now. Hopefully that makes sense. So now we're going to fill it in. The money in the end, the total money is $22.50. The money that we had to begin with was $17.50, and we got 75 cents every seashell. Every or each means times. So I got 75 cents each S or each seashell. We don't know how many shells, so that's where I put the letter. So there's our equation. Now to answer this question or to find S, I just, whoops, I'm sorry, did I do that right? No, I didn't. This is $17.25 is what we had. Sorry about that. $17.25, okay? So let me rewrite that down here. Here's our equation again. Sorry about that. Let's start that over. We had $22.50. We had $17.25 to begin with. And we're getting 75 cents per shell. All right, so now let's do this correctly. Now we'll subtract these two. Okay. And when I subtract those two, I should get $5.25. Over here, I'll get 75 cents times every shell. Divide both sides by 75. Remember again, when you're dividing, it goes in and out, and you're going to move this 2 times, so you're going to move that 2 times also. If you forgot what I mean by that, come in and study with us during third period, okay? So when I divide these two, I'll get 7, which is 7 shells. Okay, so we got number 14 now. 14 says we're going to find the value of x. In other words, we're going to solve or isolate x. 10x minus 56 equals 2x plus 32. So what makes this true? Add the opposite. Well, we got to simplify both sides. That's done. Step 2, get our variables on one side. Let's try to avoid negatives when we can. So I subtract 2x from both sides. That gets my x's on one side. So I did that first. I didn't do the 56 or the 32 first. I had to get my letters together first. Now I can isolate this variable. I'm going to work farthest away from the variable first. Do inverse operations. 8 times some number is going to equal 88. Divide by 8. And 88 divided by 8 is 11. So the answer, our solution is 11. Number 15. 15, we're going to solve this equation. Or figure out the x that makes it true. Or isolate the variable. I just said the same thing 3 different ways. So we have to distribute first because we know we simplify, then get our variables together, then isolate. Simplify means distribute and combine like terms. So half, now let me add the opposite here. Okay, and then I can get fancy and make those brackets if I want. Half of 8x is 4x. Half of negative 2 is negative 1. And then I just copy the rest of the stuff down that I'm not using. So remember, distribute, then combine like terms. Here are my like terms. 4x and 5x is 9x. Then I get my variables on one side. That's done for me. So now I isolate. I work farthest away from the variable, doing inverse operations, and I see my solution is 7. All right, 16. 16 says we have an equation, and there's some missing values in that equation. And they want us to find what's missing so that this equation is infinitely many solutions. Nope, I'm sorry. Yes, I'm right. So if it's infinitely many solutions, that means this is an identity, or the solution is all real numbers. And we know we have an identity when one side of the equation equals the other. So basically, first things first, just simplify the side that they give you. Okay, so just simplify this. So I go add the opposite, add the opposite. I got 7 negatives and 3 positives. If you do teams, that means 3x. These 3 equals 3x. Okay, see how easy that was? Just did teams there. Now, if this is going to be infinitely many solution, these two have to be the same coefficients, and these two have to be the same constants. So I have to have a 3 and then another 3 in those boxes. That would make it infinitely many. Now, for 17, it's a similar question. For 17, the directions say, what can you do for the same equation so that it is no solution? Well, we know that no solution means basically it's the same as infinitely many, but the constant's going to be different this time. So when we get our variables on one side, they'll cancel out, and we'll have 2 different numbers. So it'll be a false equation as opposed to a true equation. So what that means for this problem here is you simplify this just like we did on the last one, and I made it easy for you. I made it the same exact problem. And so what would go in these 2 boxes this time Well, this would still have to be a 3 because that would mean they would cancel out, right? And that makes a special equation, either infinitely many or no solution. So the first one has to be a 3. Now the second box can't be a 3. It can be anything except a 3. So that's why the answer is 3, and then the second one is any number other than 3. Any number other than 3. Number 18. Okay, so they give us a table. We're going to find the rate of change. It means, in other words, slope. So I'll just take the first 2 points they give us. They give us 1, 7 and 0, 5. So I just subtract my y's on top. 7 take away 5 is 2. On the bottom, subtract my x's. 1 take away 0 is 1. My slope is 2. 19. For 19, we have to... it's two proportional relationships. Find the slope. Well, if they're proportional, we can take a shortcut. If they're proportional, all I need is 1 point. So for that first one, I take 1 point, and I just put y over x, and I'm done. I don't have to do y minus y over x minus x. I just take 1 point. Okay? I can still do that, and it'll still work, but I'm allowed to take a shortcut when it's proportional. So for 20, there's a slope for the first one. I just take 1 point and put any y over its x, and I'll get 5 every single time. And then when I look at the graph, I see it's proportional. It's a line that goes to the origin, and I'll just take 1 point. So this point right here on that lattice, I go over 1, up 1. So the coordinates are 1, 1. So the slope has to be y over x, so the slope is 1. So the two slopes are 5 and 1. And last one, number 20. 20 says, which of these is proportional? Well, proportional means y equals our rate of change, kx, which is the same as saying m, slope. So we'll just use m, okay? And there's no plus or minus anything. That means it's proportional. So which one of those looks like that? Only B. Whoops. Only B looks like that. So B is proportional. All right. Hope that helps.